Okay, so let's start today's class. In the previous class, I had already completed all the string functions. So today we'll be looking at some programs where we will be using the string functions that we have already learned. Now let's take a look at the first program that we are going to do today in today's class. So, so just make a note of the program question and then we'll start with the program code. So here is the question. So write a program to input a sentence, find and display the following. Find and display the following. So at first I'll be discussing the question for a bit and then we'll jump to the um, actual program code. So the first thing that we need to find and display is the number of words present in the sentence. So the number of words in the sentence. And the second thing that we are going to find and display is the number of letters. Let's say letters, not characters, because white spaces are also characters. So let's say letters, number of letters. So the letters will basically include the alphabets in the or rather the letters in the English alphabet. So the number of letters in the sentence. So we'll assume that the sentence does not have any numbers or special characters. So we'll assume that the sentence has only letters and no numbers, or rather let's call it no digits and special characters. So this is our question here. So write a program to input a sentence, find and display the following: the number of words in the sentence and the number of letters in the sentence. We are going to assume that the sentence has only letters and it does not have any digits and special characters. Now quickly copy down the question and then we shall see how to how to approach the question and find its solution. Excuse me. Okay, so let's take a look at how we are going to solve the question. So I'm just rubbing off a portion of this just to make a bit more space. Now let's take an example and see how we are going to apply our knowledge, the functions that we have learned so far. So let's say uh, I have this following sentence. let's say my sentence is, it is raining outside. So this is the sentence. This is an example of a sentence. So we are going to take input from the user, but here we are considering a given example. So we are considering a predefined sentence. So let's see how we are going to apply our functions. So here, as you can see, this is a sentence. So essentially it will be enclosed in double quotes when we are going to specify it. And also take a look at the question. So they have asked you to find the number of words in the sentence, and they have asked you to find the number of letters. So let's first start with the first portion of the question. So how do you think we can find the number of words in the sentence? So any ideas how to find the number of words, or how to apply, in programming, it's pretty easy to just see and find out, or rather count the number of words in the sentence. So how to apply that in programming when you are writing a program? So if you think carefully, um, when we are looking at the sentence and directly, saying the sentence contains 4 words, we are practically doing some sort of calculation behind, in our brains, something behind our head. We are doing some sort of calculation and then counting the number of words. So we need to focus on that particular logic that we are applying, automatically in our brain to count the number of words in the sentence. So if you take a look at the sentence properly, there are no spaces before the sentence and after the sentence. So we do not have any spaces, but in the middle we have 1, 2 and 3 blank spaces, right? So as soon as we encounter the first blank space, so what we'll do in terms of programming, what we do is, or rather when we are looking at the sentence, we are just finding out the gaps between each word. So by looking at it, we can directly identify the gaps, and using those gaps we are counting the words. Just like we can just take a look at this sentence and directly say it has 4 words, because we are finding out where are the gaps between the words, and we are using those gaps in some way within our brains to calculate, or rather find out the number of words in the sentence. So we'll be using something similar to that when we are writing the program. So we'll start extracting each character. So we will start scanning the sentence from the first character, and we'll start extracting the characters. Now as we start extracting the characters, at some point of time we will come across this blank space that is here. So we'll come across this blank space, and what does it signify? Once we come across a blank space, it signifies that we have found one word, right? So as soon as we find a blank space, we know that we have completed one word. So we have one word here. Now again we start extracting letters from the sentence. Again we find here that there is another blank space. Therefore it means that we have again completed one more word in the sentence. So we'll again count one more word. We keep on extracting characters followed by that. So as we proceed, we again encounter a blank space here. Therefore we again are sure enough, we are assured that there is we have already found one more word. So when the program is running, it will keep on extracting characters, and once it finds a blank space, once it extracts this particular character, the blank space is also a character, so it will just compare it somehow, the extracted character, to check whether it is a blank space. As soon as it finds a blank space, there will be a counter which counts the number of words, and we'll just increase the counter by 1. So here again we find another word, so the counter value is now 3. So as you can see, we have encountered 3 words so long. And finally, on going on extracting the characters, at the end we'll come to the end of the sentence, which means we have completed the sentence and that was the last word. So the counter will increase for one last time and we'll have the value of 4 in the counter, which gives us nothing but the number of words in the sentence. So we'll use a counter. We'll extract each character one by one. If it is a space, we'll increase the word counter by 1. So let's say we have two counters. So one is called the word count. So we'll have a variable called w count, which is nothing but a counter for counting the words. So we'll have a word count variable to count the number of words in the sentence, and we'll have a variable called L count, which will count the number of letters in the sentence. Now we can do both of these operations at the same time. So we can count the number of words as well as count the number of letters at the same time. How? Since we are extracting the characters from the sentence, so as we are extracting the characters, we'll keep on counting the number of letters. So as long as it is not, so remember at the beginning we had assumed that the sentence will not have anything else apart from letters. So we do not need to worry whether a letter is a digit or a special character or something else. We only need to keep a check on the on whether the extracted character is a white space. So that's the only thing that we need to worry about in this particular program. So as we are extracting each character from the corresponding sentence, we'll keep on counting the, or rather we'll keep on increasing the value of this L count variable by 1. When will we increase the value of L count variable? Whenever we do not find a blank space. So we are extracting, let's say, let me write down this sentence once more. So let's say the sentence was, it is raining outside. Now, since we are extracting characters starting from the beginning of the sentence, so once we extract this character, we'll check whether it is a blank space or not. As you can see, it is not a blank space. So what we'll do is we'll just increment L count by 1. Again, we extract this particular character. It is again not a blank space. So let me write down the value of L count. So initially, L count is initialized to 0. The L count variable is initialized to 0. Now we start counting from here. So once we start extracting the characters, we'll keep counting. So I'm writing the variable L count here once again, and we'll be modifying the value of the variable. So initially it was 0. We extracted the first character in the sentence. It was not a blank space. So we increased the value of L count by 1. So 0 plus 1 is 1. Now L count contains the value 1. Again, since this is not a blank space, so again W count will be initialized to 0 because the number of words is initially 0. So since we have started extracting characters, so I'll also be writing the variable W count here, whose value remains 0 because we have not yet found a complete word. Now let's start from the beginning. We have extracted the first character of the sentence. The first character is not a blank space, therefore it is a letter. So the letter count is incremented by 1. We have found one letter in the sentence. But the W count remains 0 because we have not found a complete word yet. Now we move on and extract the second character in the sentence. Again, we check whether it is a blank space. We find that it is not a blank space, but it is a character, therefore we increase the L count by 1. So 1 now becomes 2. And W count remains 0 because we have not found a complete word. We proceed in a similar way. We extract the next character. Now on extracting this particular character, we see on comparing that it is a white space. Now white spaces are not counted as letters. So the L count value remains as it is without any change. But once we encounter a white space, we can be sure that we have completed one word. So what happens is the word count now increases instead of L count. So W count increases to 1, which signifies we have found one complete word already, and we move on with the extraction. So we extract the next letter, which is I. Since it is not a blank space, therefore 2 becomes 3. W count remains as it is because we have not found a complete word yet. We extract S. So 3 now becomes 4. Because S is not a blank space, it is a letter. But W count remains the same because we have not completed a word yet. Now, again, when we extract the next character and comparing, we find that it is a blank space. So what happens? Blank spaces are not letters. So L count remains as it is, but W count is changed. W count now becomes 2 because we have completed 2 words. Okay. Now W count becomes 2. We move on with the extraction. We extract the next letter, which is not a blank space. Therefore, we change the value of L count by 1, or rather increment the value of L count by 1 because it is a letter. So 4 now becomes 5. Similarly, we keep on extracting, and so finally we have 5, 6, 7, 8, 9, 10, 11. So when we have reached the letter G, L count is now 11. So here L count is already 11. We have counted 11 letters already in the sentence. W count remains 2 because we have not found a complete word yet. But here again, as soon as we extract the next character, we find that it is a blank space. Blank space again is not a letter, so L count remains as it is, no change. Whereas W count is again incremented from 2 to 3. So it's incremented by 1 because we have completed one more word. Now as you can see, we have already counted 3 words in the sentence. We keep on extracting characters. So again, starting from 11, it will count 11, 12, 13, 14. So 11, 12, 13, 14, 15, 16, 17, 18. So once we extracted, once we have extracted the last letter, the L count value will ultimately become 18. Okay. And we have come to the end of the sentence. So as you can see, as you might remember, we had assumed that the sentence did not contain any special characters. So full stop is a special character. That's why that's why I omitted that at the end. So there will be no full stop, no punctuation marks, just the letters in the sentence and the words that they form. No punctuation marks, no nothing, no digits. Okay. Now at the end we have finished extracting all the letters. So after this there are no letters to be extracted. So we have come to the end of the sentence. Now L count, the final L count value that we have is 18. So let's count it once more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have the correct L count. So the number of letters in this particular sentence is 18. The word count, as we have reached the end of the sentence, we'll just simply increase it by one more, because after this blank space we were again extracting characters and we have reached the end of the sentence. So reaching the end of the sentence would signify that we have completed one more word. So therefore we increment the value of W count by 1 at the end. Now there are 2 points to remember while changing the value of W count. So let me write those down. So I'm going to rub this off. So W count changes when, first point, the extracted character is a white space. So W count will be incremented by 1 when the extracted character is a white space. Point number 2, W count changes when end of sentence is reached. Okay, so there are two scenarios where the value of W count is incremented by 1. The first scenario is the extracted character is a white space. The second scenario is where when we have reached the end of the sentence. So to count the last word, we just increment W count by 1 after we have reached the end of the sentence. Okay. So at the end, we will have to increase W count by 1, although we do not find a white space at the end of the sentence because we have finished the sentence and the last word is left uncounted. So there are two scenarios where W count is incremented by 1. The first scenario is where we find the extracted character to be a white space, and the second case is when we have reached the end of the sentence. And meanwhile, while we are extracting the characters, as long as so what will be the condition for the incrementation of the value of L count, which is counting the number of letters? So when will L count be changed? So L count is changed, or rather we should call it, rather say it as incremented. L count is incremented only when the extracted character is not a white space. So as long as it is a white space, W count is incremented and L count is left as it is. But when it is not a white space, at that time L count is incremented by 1. When the extracted character is not a white space, every time the extracted character is not a white space, L count is incremented by 1, whereas W count remains unchanged. So remember these 2 points and the program will be pretty easy. Now, as you might have noticed, the basic operation to solve this particular program is that we have to extract characters from the sentence or the given string. So we have to extract characters from the given string. Now to do that, there was a particular function, string function, if you remember correctly. There was a particular function called char@, which used to take an integer argument, right? So this integer argument was nothing but the index. So given a sentence, we'll index it according to the array notation indexes. So we'll start from 0 indexing, we'll start indexing from 0. The first letter in the sentence is 0, indexed as 0, and so on, increasing by 1 at every step. So all the letters are indexed starting from 0. So the whole sentence is indexed, and we use the char@ function to extract characters starting from the first location up till we've reached the end of the sentence. Now, since the sentence is a user input, we do not previously know what the length of the sentence would be or how many characters the sentence would have. So therefore, we'll use one more function to find out the length of the string that has been given as an input by the user. So we had already studied the length function, the string.length function. Remember, this function returned the number of characters in the word, or rather in the string given to it, or rather on the string on which it is called. So it returns the number of characters in the string. which is nothing but the length of the characters. So we'll be using the length function to find out the length of the sentence that has been input by the user, because we do not know previously or from the beginning what sentence the user is going to enter. The only thing that we can be sure of is the user will enter a sentence that will not contain any digits, and it will not contain any special characters or punctuation marks or anything of that sort. It will only contain letters. That's the only thing that we know. So to find out the number of characters that had been entered by the user when he entered the sentence, we'll use the function called length, the string.length function, which will give us the length of the string, or rather the sentence that the user had input. And once we find out the length, it's pretty simple to start extracting from the first character. We'll use a for loop. So we'll use a for loop which will start from 0 because the indexing starts at 0. We'll run the for loop for as long as the length of the given sentence. So I will be less than equal to, let's say the string was str.length, right? So let's say I have stored the given sentence, the sentence that the user has input, in the variable str, which is a string variable. So I'll run it up till the length of the whole string, which is nothing but the value returned by str.length. So I will run from 0, which is the first index of the first character in the sentence, up till the last character in the sentence, which is nothing but 1 less than the length of the sentence. As you remember, length counts the number of characters starting from 1, so it will be 1 less than the number of characters because indexing starts from 0. So it's less than and not less than equal to. So that's the reason why it's not less than equal to, but less than string.length. And we'll keep on increasing I by 1 at every step. So this is the for loop that we are going to use to traverse the sentence and extract each character at every iteration. So on every iteration we'll extract one character. We'll do all the comparisons and increase the counters by 1 or do nothing, and all those calculations will be done inside the for loop. Finally, at the end of the for loop, we'll display the value of the counters. Now let's take a look at the actual program code. So I'm rubbing this, so I'm clearing out the board to make out more space for the program code. Now we'll take a look at the actual program code of this particular question. So we'll start with the import statement. So it's pretty simple. Now, one thing that you have to do is you have to copy down the program that I am writing right now, the program code, and you have to type it on your computer and check the outputs, how it runs. I've explained how it works. So you have to check whether it runs properly and find out the outputs. You can also use these programs in your project as well. So it's better to practice on your computer. Once you have written it down manually, it's better to write it down or type it into the computer and run it once to check whether everything is working fine. Now we have the class. So let's call the class count words underscore letters. So let's call the class count words underscore letters, since we are counting words and letters. Or we could also name it in this way. Instead of using an underscore, let's say words and letters. So class count words and letters. The class begins Now, so we can do it in two ways. One way would be to design a class, and the other way would be the process that we followed previously. So let's design a class and design functions, and then create objects and do everything else. So let's do it in a more structured way. So let's say I have a string variable defined here, string str, which will hold the sentence. I'm not writing the constructor, I'm leaving it up to the default constructor. Now I'll directly move on to the function. So there will be one function. So I'm not going to write a separate input function to take an input for the string variable. If you want, you can write a separate function to uh, to take input from the user, but I'll be combining it in one complete function. So the function that will be counting the words and letters, there itself I'll be taking an input. So I'll also be having two more variables to store the word count and the letter count. So those will be integer variables. So int l count and int w count. Well, here, although we are not initializing it, it is automatically done by the default constructor. String is initialized to null, l count is initialized, l count and w count are initialized to 0 by the default constructor. It's automatically done. So we have three class variables. The first one is a string variable. So let me write down the comment lines. So this variable stores the input string or sentence. So the str variable basically stores the input string or sentence. L count variable counts the letters. W count variable counts the number of words. Counts the words. Let's proceed with our program. Now we are going to write down the function. So the function does not return any value. So it will be a void function. So void. Let's call the function count w and l. So I'm just giving it a fancy name. You could rename it in any way. So I'm calling it count WNL, which stands for count words and letters. So count WNL. It does not take any arguments because we already have the sentence variable as a class variable here. So it does not take any arguments when it is called. We start the function. Inside the function, since we are taking an input for the sentence in this particular function, we'll have to define the scanner class here. Scanner sc is equal to new scanner system dot in. Next, we'll take input from the user for the sentence. So sopln enter a sentence. So we'll display a message to the user and we will take an input. So we already have the variable str. So str is equal to sc dot next line. There's one more important thing to remember here. Normally when we take string inputs, we just write sc.next and function brackets, so the for opening bracket and the closing bracket. Now but when we have to take input for sentences that is more than one word, we have to use the function next line, because the next function terminates on a white space or when you press enter, whereas so next function terminates when you press the space bar or you press the enter. So it will stop taking input after you press the space bar. But in sentences we have white spaces. Therefore we'll be using the function next line, which can take inputs even if you press the white space but terminates on pressing enter. So let me write down a comment line there. This function is used to take sentence input. So the next line function is used to take an input when you are entering a sentence. Now we have the sentence. Once we have the sentence in the variable str, we'll again, just to be sure, we'll initialize w count to 0. Also we'll initialize L count to 0 before we begin actually counting. So we are initializing, rather resetting the values of W count and L count before we start the for loop. Now I hope you have finished copying it down up till here. So I'll be rubbing off the whole thing. So let me just rub off the first portion. So I'm keeping the portion below. Or rather, let me just, so as to not confuse you. So you could just watch the video later. If you are unable to copy it down due to the speed, you can just watch it later and copy down the program code. So the last sentence that we had written was we had initialized W count and L count to 0. Rather, we had reset the values of L count and W count. Now the next thing that we will do is we will use one more variable called length, or len, which is nothing but the length of the string, and we will call str.length function to store the length of the string in this particular variable. So the length variable, this basically calculates and stores the length of sentence. So it calculates and stores the length of the sentence in the len variable. So we call the str.length function. Now we'll start writing our for loop. So for int I is equal to 0. So we start from the 0th index. I is less than len, which is the length of the sentence, and I++. So that is the for loop. Now inside the for loop, we'll do something. What are we going to do? We have to define a character variable ch to store the extracted character, and then we'll call the charact function. on the string that contains the sentence. So as you remember, all string functions are called on the string variable upon which we are working. So the length function is called on the string variable str because we are working on str. The caret function will similarly also be called on the variable str. So str dot caret I, where I is nothing but the loop variable, or rather the index variable. Extract character at index I. So the value of I is nothing but the index value. It will extract the character at location I. Now once we have the extracted character in the variable ch, we are going to check whether ch is a blank space. How do we do that? Simply use the comparison operator and we check whether it is a blank space. Now if ch or the extracted character is a blank space, we have found a word, which means we have to increment w count by 1. So w count plus plus. So we'll simply write w count plus plus. Next, if ch is not a blank space, which comes under the else part, we do L count plus plus. See, it's pretty easy. Once you understand the logic of the program, it's pretty easy to write down the program. I have the for loop which cycles from the first letter or traverses the sentence starting from the first character up till the last character. I've already found the length of the sentence which I'm using in the for loop. Now I'm in the character variable ch, I'm extracting each character at the current position. I'm checking whether that character is a blank space. If it is a blank space, w count is incremented, which means I found a word. Otherwise, if it is not a blank space, L count is incremented, which means I found a letter. And simply my for loop ends here. So that's all I need to do inside the for loop. So let me write down 2 more comment lines. Here it counts words, here it counts letters. Next, as you can see, the number of words in the sentence are 1 more than the number of spaces. If you remember the example, the number of words in the sentence was 1 more than the number of spaces between each word. So in our example, it is raining today. We had 3 spaces in between but 4 words. So let me write it down here. Number of words. So this is just a mathematical way to represent the logic. Number of words in sentence is equal to number of blank space plus 1. So the number of words in the sentence is nothing but equal to the number of blank spaces plus 1. So it is raining today. We have 3 blank spaces, but there are 4 words. So 3 plus 1 is 4. Here, as you can see, W count is counting the number of blank spaces. So whenever ch is equal to a blank space, W count is incremented. It is nothing but simply counting the blank spaces. Again, here I have said that the number of words is number of blank spaces plus 1. So that is what we are going to do. So W count is incremented by 1. So this is a multi-line comment. Yes, yeah. You can just open the link and you can just, yeah. So essentially we are counting the um, number of blank spaces inside the for loop, but since the number of words in the sentence is one more than the number of blank spaces, so we will have to increase W count by 1. So W count plus plus. This gives us the actual number of words. Actual number of words. Now we have the number of letters in the sentence as well as we have the number of words in the sentence. The only thing that remains is to display the values of L count and W count. So remember, we are still within the void count WNL function. So we are still within the void count WNL function. Inside that we had been doing all these calculations. Now before we end the function, we will have to display the values of W count and L count. So SOPLN number of letters plus the value of L count. So this plus is nothing but concatenating the two values. One is this and one is this. Remember, we had learnt about the concat function when we were discussing the string functions. So this plus operator here does the job of the concat function. So this is converted to a string. The value of L count, which is an integer value, is converted to string. These two strings are joined together and then displayed. So SOPLN number of letters concatenated with the letter count, value of the letter count variable. And lastly, one more SOPLN. And lastly, we have one more SOPLN which displays the number of words. So now that we have finished displaying the number of letters and the number of words, the count WNL function ends here. So let me write down one more comment line here. End of count WNL function. So that is the end of our count WNL function. So we have defined variables, class variables, we have defined a function to do everything. Now we will define the main function where we are going to define objects and then call this particular function. So let's define the main function. Public static void main. Now inside the main function, we'll define an object of the class. So we define an object of the class. So as if you remember, the class was called count words, count words and letters. So if you remember, the class was called count words and letters. So define an object obj is equal to new and the constructor. So count words and letters. So this is the constructor. Now that we have defined an object, we'll use the object to call the function obj dot. So the function was called count wnl. It did not take any arguments, and just by calling this function, we have done everything that was defined inside the function. So we have taken an input, we have counted the letters and words, we have displayed them, and our main function ends here and the class ends here. So this is the end of our class count words and letters. So our main function is pretty simple and short, just two sentences or two lines of code. We define an object, we use the object to call the function, and we are done. So that's the whole program for counting letters and words using the class designing method, or rather the class designing paradigm. So I hope you have copied down the whole program. Make sure to write down, type it in your computer, and check for different values of sentences. So try entering different sentences and check the values. And that's all for today's class. So we almost took up one whole class for one particular program. So the next day we are going to do one more program. So we'll be doing programs, quite a few programs in these coming classes. So I hope you have understood today's program. You have understood the logic behind the program as well as the program code. The next day we are going to look at a few more programs. So until next day, thank you for coming to today's class and have a nice day.